Hello, I'm Professor Lily Wu. I would like to talk to you guys about an exciting project that we have at UCI called microfluidics or lab on chip. So lab on chip means that you actually shrink a chemical analysis process. So imagine you actually are in the lab, you're mixing your solutions and you're having some kind of chemical reaction, and you do all that on a single chip, a handheld chip like this. So it's called lab on chip and also known as microfluidics. So you're shrinking down an entire lab operation onto a small chip like this. And the benefits are you can actually do high throughput reactions in a very fast amount of time, so increases process efficiency. And because it uses less chemicals, so if you have very expensive chemicals like proteins, then you actually save a lot of money for that. And you can also do all kinds of experiments in a very small format. So if the chemical is dangerous, it minimizes the danger. So there are a lot of benefits that's going to research for lab on chip devices. So I have a few here. So the project that we have at UCI is to use microfluidics to detect the concentration level of a solution dye called fluorescein. And fluorescein typically is a chemical used for dry eye disease detection. So let's say you have dry eye disease, you go to the doctor's office, they will actually put fluorescein into your eyes, they will take your tears and they go to this big machine called fluorophotometer to detect the level of the concentration for fluorescein to see whether you have dry eye disease or not. And instead of an expensive machine, we can do everything on a chip like this. And this is a couple previous students' project that have came up with different designs for this type of lab on a chip project. So let me show you really quick of the project and what it actually composes of. So as I mentioned, there is the lab on a chip. Okay, so in this case, you'll have the chip over here, as you can see, and also electronics. There is a detector that detects the concentration level by sensing the color change of the fluid. So basically this is an RGB sensor, is also known as a color sensor, that actually detect the color change of the fluid inside, and it's controlled by a very simple circuit board by a mini computer underneath here called a Arduino microcontroller. So the detection using the color sensor over here, it's being programmed and detected by using a simple circuitry using a mini computer called a microcontroller. And this is an Arduino microcontroller over here, and you can see the simple circuitry over here that whatever concentration level shows up, you will have LED light as indicator to indicate if it's actually a low concentration or if it's a high concentration. And so there's also very interesting chemistry phenomena over here. Is the solution we use is a fluorescein dye. So it gets excited if you shine a certain colored light on there. In this case, we will use a blue light to excite the photons in the solution, and you will actually see when you shine the blue light onto the solution, you will actually see the green light because the energy level of the electrons being excited, and it will actually jump a level and also relaxes and releasing energy, and therefore we see a different color of the solution. Which if you actually join the project, you will get to see that phenomenon. And so this is several designs that our students have. In this case, you'll see the outside housing is actually 3D printed, so you can have the electronics outside and a housing for your chip to completely block out the ambient light for your light detection, for the color detection. And this group actually hid their electronics inside a completely enclosed box, and you have the option to design different shape of your housing if you want. In this case, this whole set looks like kind of like a little mushroom, but this is the creativity you'll be allowed in this project to actually 3D print your housing. Okay, so in this platform, the student actually had their chip in the second level and then all the electronics at the bottom. And a third example I want to show over here is a student made their chip looking like a syringe pump with the detector actually being stabilized on a hinge over here and the microfluidic chip underneath, and all the electronics is enclosed in this box over here.